All right, now that we've practiced with rewriting logs into exponential form and from exponential form into log form, we're going to start practicing evaluating logs. So the title of today's notes will be evaluating and solving using logs. And then make sure you write today's date in the top corner of your notes. All right, so there's a formula called change of base, which we use when we're dealing with logs. So it says that if you have a log in this form, and I'm going to use letters, so log base b of x I can rewrite this to evaluate it by taking the log of x over the log of b. So whatever the number is in the x position, you put that on the top, and whatever the number is in the bottom, in the b position, you put that on the bottom. So if I ask you to evaluate a log, you can actually calculate the number that it represents for that problem. So let's take a look at some examples. If I ask you to evaluate and I gave you this problem, log base 3 of 9. Using the change of base formula, all I would have to do is rewrite this as the log of 9, so log 9 over log 3. And using your calculator, we're going to use this log button here. So we've probably never used that before until now. We're going to use this log button. And I'm just going to type it in exactly as I see it. So I have log 9. You have to close parentheses. That's important. Divided by log 3. So doing that, that gives me 2. So when I evaluate that, log 3 of 9 is equal to 2. And what that means is that when I raise 3 to the second power, it gives me 9. That's the other way to think about it. Because remember, if we rewrote this into exponential form, it'd be 3 to some power equals 9. And we're just looking for what that power is. And this is the way that you can do it algebraically. So this is the exponent on 3. That gives me 9. Another example. Let's say I gave you log base 7 of 49. So using the change of base formula, you take log of 49 over log 7. And we can just use your calculator again. Remember the log key is next to the number 7. So I do log 49 divided by log 7. The common mistake will be forgetting to close the parentheses. You got to make sure you close the parentheses. And doing that again, we get 2, which means the exponent on 7 to get me to 49 is 2, which makes sense. 7 squared is 49. Let's try another one. We'll do log base 5 of 1 over 25. So I rewrite it in my change of base form, where I take log 1 over 25 over log 5. So with this one, you got to be careful because you're typing in a fraction. It's 1 over 25. So I would type in log 1 divided by 25, close parentheses, divided by log 5. And in this case, my exponent is negative 2. So evaluating these, I just do the change of base formula. And I can find the exponent that makes these true. So this formula will work on any calculator that has the log button. But with these TI-84s that we have in class, there's actually another button you could press that also works. So if you go to math underneath the green key, and you have all these choices. Normally we do math and then fraction. We're going to scroll down, and you're going to see that there's a log button in letter A. So if I go to log base and I hit enter, notice that it looks just like how the problem is set up. It's got log, and then I can type in those numbers, 3 and 9, and hit enter, and it'll give me the answer. So evaluating that tells me that the exponent on log base 3 of 9 is 2. So again, I can do it for this one. You should get the same answer. And you can actually go up if you want and go backwards to get to A. Same thing, log base 7 of 49. So I just type in the numbers as I see them, and that tells me the exponent that makes that true. So these answers should be matching up with what we did already. 5 of 125. And that's where negative 2 came from. So that's evaluating using logs. We can then now apply that information to solving. So we're going to try solving some equations. Okay, so for these examples, we're going to have to solve. So you're going to be given an equation, 4 to the x equals 64. So now that we know how to work with logs, we can rewrite this equation using log form. So I can rewrite this saying log base 4 of 64 equals x. And once I get into this form, I can do the change of base formula that I used up here on the top. So now I can just rewrite this as log 64 over log 4. Or if you wanted to use the shortcut on the calculator, you could also just use the calculator shortcut. So doing log 64 divided by log 4, I find that the value for x is 3. And again, what that means is that when I plug in 3 back into my original equation, that should be a true statement. 4 to the third is 64, so 64 equals 64, so we're good. So using logs helps us to figure out a way to determine what the exponent is in the equation. Let's try another example. All right, so we'll do 5 to the x equals 625. So to solve this, we have to rewrite this in log form. So it's going to be log base 5 of 625 equals my exponent, which is x. And now I can do that change of base formula where I take log of 625 divided by log 5. Typing that into the equation in the calculator. Log 625 divided by log 5. my exponent there is 4. Which should make sense because 5 to the 4th is 625. Another way to look at that, remember, is that you could do the shortcut on the TI-84s when you hit math, and then you just go to log base. And I could just type it in at this step, log base 5 of 625, and you'll get the same exponent. So either method works. I just want to make sure you know how to use other calculators. It might not have that function to solve using logs. So you'd have to do the long way with change of base formula. All right, so you should be ready to go to evaluate and solve some equations.